So for our next presenter, he's already right here with me, is Gert Jekyll. He's the Senior Manager of Data Analytics Test Systems at ZF Group. And he started his career in mechanical engineering. And for the last 20 years, he's worked within production IT. Welcome, Gert.
Thank you, Sasha, for the warm welcome. And thanks for having me in today's data talks. Pleasure to present our team's work today here. I'm going to introduce how we from ZF Friedrichshafen Test System help our customers to reduce their efforts in physical testing. However, let me begin with a few sentences about ZF Group. ZF is a global technology company which supplies systems for passenger cars, commercial vehicles, and industrial technology. Founded in 1915, ZF has evolved from a supplier specialized in aviation technology to global mobility technology company. ZF Group is represented within 188 production locations in 31 countries. And in 2021, ZF achieved sales of 38 billion euro with approximately 160,000 employees. Test Systems belongs to the industry division of ZF Group. The industry division itself is in charge of transmissions for windmills, ships, tunnel drilling machines, machine tools, forklifts, and, for instance, ropeways. We develop the test systems for the transmissions and axles of all these machines and equipment. We also develop test systems for tire and wheels, battery simulation testing, and sure, today, test systems for e-mobility is a key topic for us. Transmission components and oils and brakes is something we are also delivering in for research areas. Complex mechatronic and electronic products like transmissions or axles are usually tested 100% before they will be shipped to customers. That's important because it's a key topic we want to reduce a little bit. As ZF is moving full speed ahead with digitalization of our products, the digitalization of our production and testing goes along with digitalization challenges as well. Based on a solid foundation of 35 years experience how to develop, produce and deliver such test systems in automotive industry, ZF Test System decided to extend business towards digital products. Our digital products are based on highly repeatable tests, high quality repeatable tests and process understanding in the discrete production process of automotive area. The final production tests in these production steps are usually called end-of-line tests, and they will be performed near or at the end of the value chain. All products and process variants show up at that point. Similar to a firewall, the primary goal of the end-of-line testing is the protection of the customer from remaining risk of production failures. Results of the test need to be stored. The acquisition of characteristic measurements and the time series data is key for the daily work of responsible test engineers and the basis to perform advanced analytics. As most manufacturing execution systems are lacking the ability to store time series data, we developed our product Tattoo, which is able to store characteristic measurements and time series data of the testing processes. On top of our data, Pond Tattoo, we provide 4 digital products which are mainly programmed with Knime. First, guided data wrangling. It helps to prepare discrete manufacturing data for advanced analytics. Second, maintenance of limits, which automate the setting of automizes the setting of unbiased limits. This is the basis for improved data quality and reduces the workload of the test engineers. Third, non-conformance reasoning that is designed to increase first-pass yield. Finally, detection of anomalies in acoustic tests or transmissions which reduce the risk of customer complaints. The data of end-of-line tests always contain some marks from the already performed production steps, like assembly or manufacturing. With analytics, we use these marks to generate improvements by optimization of production parameters to reduce the scrap internal rejects or even tests. How do we work? In times of transformation, when change and continues to accelerate, ZF gives orientation to the employees with a program we call ZF Way. This is providing five timeless principles that help ZF as a company and organization to rise over decades to become a leading mobility specialist. They are passion, anticipation, diversity, empowerment, and accountability. Within the projects to reduce physical testing, my associates of different departments walk down the ZF way, contributing their technical and personal expertise and engagement. Due to travel restrictions in the past 2 years, the teams enforced perfect virtual collaboration, and I want to thank all of them by highlighting some representatives of the departments. The perfect agile cooperation of electronic testing expertise, IT integration, and testing expertise to define proper data science solutions was a key towards transformation of existing processes towards data-driven decisions and digitalization. Now let's take a look back where we started. Electronic component production is a part of ZF's value chain. After an electronic board has been produced in the assembly, an in-circuit tester is the next step. The in-circuit test does exactly what the name indicates, a check of all the internal electronic functions. On this basis, the test decides whether the board is scrap or need to be retested or repaired. I skipped retesting from the process overview as they don't help in scenarios where you want to work with models. Scrap handling isn't visualized as well, but is performed after each test. After the in-circuit test, the boards are moved to a workplace to protect against environmental influences. In some cases, such boards are placed in liquids like hot oil. After this process, the so-called run-in test is performed. You can think of a full load test of the electronics of the enclosed boards with the electronics at -40 plus 120 and 20 degrees Celsius. The final assembly step performs the placement of final covering, plugs, cables, etc. You already got the process idea that after the final state of the production before it's shipped, another test needs to be performed. I'm sure not only controllers in the audience start wondering, 3 times 100% test, is this really necessary? At the moment, this is a process which has been accepted by our customers and us. In the next slides, I will introduce you to the idea of optimization. Let's just focus on the first test step. What if we can use the results of the in-circuit test to detect anomalies and reduce the run-in test just to the anomalies? This means that the additional virtual test step is required to identify boards that need to be sent to the run-in basis of the models is the data of the in-circuit test. We have added some additional value to existing traceability data by developing this anomaly detection. Traceability data is stored usually in MES systems or now in MES platforms. First, minimum viable products have been launched for this process developed and launched in 2019. In 2020, we have been able to develop a solid MVP which demonstrated enough quality and robustness that the design of a new assembly line and test line included the reduced run-in, testbed, and the virtual testbed. Currently, we are in the production ramp-up phase of the newest, latest transmission controls and our virtual testbed based on Knime Executor. What saving do we expect from the decision taken? Firstly, we need to keep our product quality stable. That is something you can't discuss with your customers. Our MVPs showed that there is a good chance to improve even quality. However, this is something I can't explain today. Secondly, we achieved a 7-digit cost saving through reduced investment in run-in test equipment. Thirdly, we expect annual savings in energy cost in the 7-digit range annually, which also help us to achieve our environmental goals. In the following slide, I will introduce you to how the solution works. The simplified process looks like this. Receive result data from the tester, do some pre-processing, execute the model, and send back the answer to manufacturing execution system. The virtual testbed receives a JSON file with product information and the measurement information. Each measurement is additionally provided with upper and lower limits and the status that the testing program has already set for the measurement and the complete test. Our key is the serial number of the electronic board. Today, the model execution takes between 2 and 11 seconds, which is unacceptably long in most production situations where the process stops till the answer is provided. Luckily, the model's answer is not required before the machine reaches the enclosing station. In our case, the material movement to the enclosing station takes approximately 30 seconds. This example makes clear that we need to work on improvements. The models must be executed directly on testers which are equipped with industrial computers or some really special PLCs. The next slide provides an overview of the virtual testbed we developed. Container technology is our basis for robust and scalable infrastructure. The Knime Executor is running in an OpenShift pod in our internal cloud. For us, that is the basis to scale into the world. Today, we use available Knime nodes for models like gradient boosted tree, regression, random forest. And in some use cases, we implemented a set of rules or special filters in case we can't work with models. For instance, when we start a new production, you just do not know enough about the product because you see its behavior the first time in the testers. First tests with neural networks have been performed, and the integration into the virtual tests is the future to do. Application logging is sent to Azure Data Lake. We decided to use Azure Monitoring to implement combined infrastructure and application monitoring. Let's have a look how we work with models. All production and test steps report their data to manufacturing execution systems. From there, we replicate the necessary data to ZF Data Lake, which relies on Microsoft Azure. Our Knime executor for model creation is based on Knime Factory. I'm sure most of you are familiar with the concept and have a more deep knowledge than I, and therefore I will skip this part. Currently, we are using Knime standards for model deployment. In future, this might change since we need to have a solution that can be deployed down to the industrial PC level of such a complex tester. Every new product has a ramp-up phase in which the production processes are started and improved with a smaller amount of products. We will use the safe launch phase to create first models, as the run-in test can be performed 100% and will provide good feedback for the model quality. Change management within our organization and with our test suppliers will be more critical for further rollouts than the technical side of such an implementation. Change always requires urgency and trust between partners. Since developing new concepts always includes the risk to fail, one key to success is creating teams that are willing to work with the risk and invest in building trust. So let's move on to the overview of our future challenges. The process enhancements I have explained have been defined as future standards for our area of electronic testing. Thus, it requires a scalable and maintainable solution. Additionally, responsible managers from the area of mechanical manufacturing share the idea of possible improvements through virtual tests. This clearly addresses the need to make use of models in areas where answers need to be provided within the production cycle. Hence, we need to work on optimization of the models. In addition, we need to find a technical deploying strategy. PLC vendors already provide PLCs with model execution capabilities for real-time applications. The question for us will be how to define the connection between IT with Kubernetes, Knime and so on, and industrial IoT for models. For customers being locked into a provider's ecosystem, it's always a risk, the login. However, Knime, with its large partner network, reduces this risk. With a cooperative platform Knime, we can provide solutions that enable customers to connect their second or third production line or implement minor process changes by themselves. I think you already heard from my colleague before with the aircraft data, a similar approach. We provide our applications with a simple plant license and an annual software maintenance fee. Integration service and customer service are supplied as well. For our customers, the capabilities of Knime platform and our knowledge of business process combined with IT are a perfect fit. We are going to deliver some bricks to our customers' transportation paths towards digitalization and data-driven decisions. Thank you for paying attention, and now I need to hand over to Sasha again. Thank you.
Thank you, Garrett. That was a great presentation, and I'll see you in a little bit for the Q&A.